Hello everyone. This video will show how to identify horizontal asymptote, vertical asymptotes, holes, and discontinuities given a rational function. Before we go over some examples, let's have a review on the basics of how to determine horizontal asymptote, vertical asymptotes, hole, and discontinuities of a rational function. Horizontal asymptotes of rational function describes the behavior of the function as x approaches towards positive infinity towards the right or as x approaches towards negative infinity to the left. To find it, there are three cases for this. The first case is when the degree of the numerator is less than the degree of the denominator. The horizontal asymptote is always y equals 0. For the second case, when the degree of the numerator and the degree of the denominator of the rational function is equal, then to determine its horizontal asymptote, we are going to divide the leading coefficients of the numerator and the denominator. For case 3, the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. However, the graph may have an oblique or slant asymptote instead. To determine the equation of the oblique or slant asymptote, we're going to divide the given rational function. We can use long division for it. Now, how do we find the vertical asymptote of a rational equation? Vertical asymptotes occurs at values of x where the denominator equals 0, provided that these points don't cancel out with the numerator. To determine the vertical asymptote, we have to make sure that we simplified the given rational expression by canceling any common terms before proceeding these steps. So these are the steps to determine the vertical asymptote. So once we cancel out common terms, we set the denominator equal to 0 and we solve for x. And this will represent the vertical asymptote. So how do we find the holes in rational functions? Holes in rational functions occur when a factor in the numerator and the denominator cancels out. At these points, the function is undefined. So these are the steps to determine how to find the holes of a rational function. First, we factor out the numerator and the denominator. After that, we are going to look for common factors, and whatever's common factor, we cancel them out. And after that, we solve for the canceled factors. Whatever was canceled, we solve for x. And this represents the whole, the x coordinate of the whole. And we can substitute this x value into the simplified function in step 2. And we will be able to determine the y coordinate of the whole. Now let's go over the two types of discontinuities. Discontinuities come in two forms. The removable discontinuities, this represents the whole, and the non-removable discontinuities, this represents the vertical asymptote. Okay, now let's go over with some example. Let's start off with the first example here. Okay, so let's first find the horizontal asymptote for this given function. To determine the horizontal asymptote, we're going to look at the degree of the numerator and the denominator. In this case, the degree of the numerator here is 2 and the degree of the denominator is 3, which means that the degree of the numerator is less than the degree of the denominator. So this is an example of the first case. We remember that if it's the first case, automatic, our horizontal asymptote is y equals 0. So I'm going to go ahead and write that down here. Now let's move on to the vertical asymptote. To determine the vertical asymptote, all we need to do is to first factor out this given function and we cancel any common terms. And so I go ahead and rewrite that down here. Looking at the denominator here, x is the common factor. So I will factor out x and this becomes. So again, to determine the vertical asymptote, we're going to simplify this given function that we have right here by canceling any common terms. So I go ahead and use the box and diamond to factor out these two. So we're going to start with x squared minus x minus 2. So I'm going to factor this x squared plus 4x plus 3, again, using the box and diamond. So this is the factored form for this function that we have up there. So what are we going to do next is we are going to cancel out common terms. In this case right here, we have x plus 1 and x plus 1 are common factors. So we cancel them out. So the leftover would be, to determine the vertical asymptote, we are going to set the denominator equal to 0. So I'm going to go ahead and write that up here. So setting this equal to 0, so we have x times x plus 3 equals 0. So we can go ahead and say that the first one, using the zero product property, we can go ahead and say that the first x here is equal to 0, and the other x would be x plus 3 equals 0. That's this one right here. And so we can add both sides by 3. And so the other vertical asymptote is x equals negative 3, because we're going to subtract 3 from both sides. So these two are the vertical asymptotes for this function that we have up here. Now let's determine the wholes for this function. To determine the wholes, we are going to use the cancelled terms, which in this case is x plus 1, and we equal that to 0 and solve for x. So in this case right here, our cancelled term is x plus 1. Again, we equal that to 0. So we go ahead and solve for x by itself. So this is the x coordinate of our whole. To find the y coordinate, what are we going to do is we are going to plug this into the factored form. So this one right here, we're going to plug this x, which is equal to negative 1, to its simplest form or factored form to solve for y. So I'm going to go ahead and show that work up here. So we can go ahead and say that the coordinate of the whole is negative 1 3/2. So let's find where this function is discontinuous at. Every function is discontinuous at its whole. So that is x is equal to negative 1. So that's the first point where this graph is discontinuous. And another thing, we always remember that it is also discontinuous at its vertical asymptote. In this case right here, we have x is equal to 0 and x is equal to negative 3. Now let's look at the graph of this function right here. Notice that the two vertical asymptotes are x equals 0 and x equals negative 3. And the horizontal asymptote is y equals 0. Please also notice that in the graph, the point negative 1 3/2 is the whole. It is undefined at that point. Now let's have another example. Okay, so let's find first the horizontal asymptote for this given function. Looking at this function right here, the degree of the numerator is 2 and the degree of the denominator is 2. So that means this is an example of case 2. To find the equation for the horizontal asymptote for second case, all we need to do is to divide the coefficients of the first term that we have here and the coefficient that we have down here. So that would be y equals 1 over 1, which is pretty much telling us that our horizontal asymptote is at y equals 1. Now let's find the vertical asymptote for this function. To determine the vertical asymptote, we are supposed to simplify this given function right here by canceling any common terms. To do this, I'm going to use the box and diamond to factor out x squared minus 4. So the numerator can be written as x plus 2, x minus 2. Now I'm going to factor x squared plus 4x minus 5. So I've factored out x squared plus 4x minus 5 using the box and diamond. So this is the factored form. So what are we going to do is to cross out common factors. In this case right here, we don't have any common factors. So we go ahead and determine the vertical asymptotes by setting the denominators equal to 0. So I'm going to go ahead and show that work down here. So these are the two vertical asymptotes for this graph. Now let's determine the whole for this function. To determine the whole, we're going to find out the common factors on this portion right here. In this case, there are no common factors. So that means there is no whole in this graph. From here, we can go ahead and say that this graph is discontinuous at... A graph is discontinuous at its whole, and there's no whole in this, and the graph is discontinuous at its vertical asymptotes. So this graph is discontinuous at x equals 1 and x equals negative 5. Now let's look at the graph of this function. So if you notice, our horizontal asymptote is y equals 1 and our vertical asymptotes are x equals 1 and x equals negative 5. Again, there is no whole in this function. And this is discontinuous at its vertical asymptote, x equals 1 and x equals negative 5. Now let's have another example. Now let's determine the horizontal asymptote for this function right here. We look at the degree of the numerator, which is 3, and the degree of the denominator is 2. This tells us that this is an example of case number 3. So for case number 3, there is no horizontal asymptote for this function. However, this can have a slant asymptote. To determine the slant asymptote, we are going to use long division to divide this numerator with the denominator. So I'm going to go ahead and write that down here. So what I did was I wrote the numerator here and then the denominator down here. I placed a placeholder for 0x and 0x right here. So we're going to divide this. X cubed divided by x squared is x. And we multiply this x with each of the terms here. So x times x squared is x cubed. And then we have x times 0x is 0x squared. And then we have x times negative 4 is negative 4x. So we're going to subtract these two together. So then this would come out... negative 2 minus 0 is negative 2x squared, and then we have a negative 4x. Now we bring down the 0, and we're going to divide the first term over the first term here. So that is negative 2x squared divided by x squared is negative 2, and then we multiply negative 2 to each of these. So this is negative 2x squared. We have minus 0x, and then that is a positive 8. And then we are going to subtract these two together. So the answer to that would be, this cancels out. This is 4x, and then this is negative 8. The equation for the horizontal asymptote is x minus 2. So this is the horizontal equation of the horizontal asymptote. Now let's determine the vertical asymptote. To do this, we are going to factor this out and cancel out common terms. So in this case right here, x squared is the common factor, so we get x minus 2. And then for the denominator, we have x squared minus 4 is actually x plus 2 times x minus 2. From here, we can cross out the x minus 2 and x minus 2, leaving us with our f of x in simplest form is x squared over x plus 2. To find the vertical asymptote, we're going to set the denominator equal to 0. And then we solve for x. So I'm just going to go ahead and show that work down here. So the equation for the vertical asymptote is x equals negative 2. Now let's find the whole of this function. The whole of rational function is coming from the one that have been crossed out. So in this case right here, we have x minus 2. So we're going to set that equal to 0 and we solve for x. So this is the x coordinate of our whole. Now let's find the y coordinate for this. To do this, we're going to use the simplified form right here. And then we plug in these x to solve for y. So the coordinate of the whole is at 2, 1. So based from this graph will be discontinuous at... Every rational function will be discontinuous at its whole. So that is at x is equal to 2. And then it's also discontinuous at its vertical asymptote, which is x is equal to negative 2. Now let's look at the graph of this function. So if you notice, the vertical asymptote is x equals negative 2. And the horizontal asymptote is, or the slant asymptote, is actually y equals x minus 2. And if you notice, there is a hole at 2, 1. So that is how we find the vertical asymptote, horizontal asymptote, and hole for every rational function.